Triangle man. Triangle hand hates teacher man. They have a fight. Teacher wins. Triangle man. Triangle man. Triangle man. Triangle man wants to find out if he's congruent with another triangle man. So they compare sides. All sides are congruent. The triangles are the same. Triangle man. So we have two triangles. We have to determine if they're congruent. And we know from before that corresponding parts of congruent triangles are congruent. And so we can actually say the converse of that statement is also true. That if all corresponding parts of two triangles are congruent, then the two triangles are congruent. Because the converse is true. Note the book sometimes uses this term CPC-TC as opposed to CPC-FC. The T stands for triangle instead of figure. As far as I'm concerned, they're interchangeable. If you put one, but it was actually a figure, not a triangle, like I'll still accept it. It's not a big deal. So CPC-FC you can use for both taking two triangles and figuring out that the parts are congruent, or taking two triangles with parts that are congruent and figuring out that the triangles are congruent. Either way, it's totally fine with me. So that just means CPC-TC is a biconditional statement because both the converse and the original statement are both true. So that's our definition of a biconditional statement. But we'll see an example here. I have two triangles. I have triangle GHJ, and then I have triangle KLM. Note here the corresponding, point. This part corresponds with this part. This part corresponds with this point. This point corresponds with this point. And there's six parts to each triangle. There are three sides, and then there are three angles. And we need all six to be congruent before we can say that these two triangles are congruent at this point. So, for example, we could say that this side is congruent to this side, this angle is congruent to this angle, this side is congruent to this side, this angle is congruent to this angle, this angle is 90 degrees, right? This one's 90 degrees, and then finally 1 meter, 1 meter. So, since all six parts are congruent, we can say, yes, these two triangles are congruent using CPC-TC or CPC-FC. I'm fine with that one. Note here, though, we can also prove that they're not congruent by simply having one of the corresponding sides not be congruent. So for example, if we were to look, that's a bad example. We'll go to number 5 here, right? We can say, oh, hey, are these guys congruent? Well, it doesn't say anything about BD and DC and GF and GE, so we don't know for sure, but then we can look at the angles and we can say, oh, wait, this angle is 60 degrees, cool, just like this one, cool. But then if we go to this other one, and we realize that this angle is 41 degrees and the corresponding angle is 42, we can go, therefore they are not congruent. And we know that for sure. We don't have to say that, oh, they might be, they might not be. We know that for sure because the corresponding angles are different. So they're not congruent. If it was unknown information like this side, if we just knew one angle, that would be, oh, we don't have enough information to tell. But since we have these angles that are wrong, we know that for sure.